Today, we're going to tackle a really interesting idea where ancient text and modern science seem to collide. The big idea is this. We look up and see one sky, but science, well, science sees seven. So let me ask you a simple question. If you step outside right now and just look up, how many skies do you see? It's kind of a trick question, right? You see one. Just one big blue dome over our heads. It feels like a single thing, this huge continuous space. But what if I told you that what we see as one is actually a really complex system made of many different layers? And that brings us to the heart of the mystery. We have this text written 1,400 years ago, long before we had satellites or even weather balloons, and it makes this incredibly specific claim. It says the sky isn't one, but seven heavens. And here's the kicker, that each one has its own specific job, its own command. Now that just doesn't line up with what you see with your own eyes, so let's dig in and see what modern science has to say about all this.
All right, to get to the bottom of this, we're going to take a little trip. Think of it as an elevator ride, going straight up through that big blue expanse. Because it turns out, scientists have discovered our atmosphere is anything but simple. There's a whole hidden structure up there.
The best way to picture it is like a giant, invisible layer cake. Yeah, really. Our atmosphere isn't just one big blob of air. It's actually stacked with these totally distinct zones. And each layer has its own unique temperature, its own pressure, and its own chemical makeup. They're genuinely different from each other. So let's start at the very bottom, right here where we live. This is the troposphere. It's the air you're breathing as you listen to this. This layer holds pretty much all of the atmosphere's water vapor, and that's a huge deal because it means this is where all our weather happens. Clouds, rain, storms, you name it. You could say its command is to create the climate we experience every day. Okay, moving up a floor on our elevator, we hit the stratosphere. And you've definitely heard of this one because it's home to a real VIP, the ozone layer. This is a perfect example of a layer with a specific job. The stratosphere's command is to act like a giant sunscreen for the entire planet. It absorbs most of the sun's really harmful UV radiation, which is what makes life on the surface possible in the first place. Next up, we have a two-for-one, the mesosphere and the thermosphere. The mesosphere is like our cosmic bodyguard. It's the layer where most meteors burn up and become shooting stars. Then, above that, you get the thermosphere, which is just a place of wild extremes. The temperature there is technically scorching hot, but the air is so thin, the molecules are so far apart, that you would actually feel like you're freezing to death.
Weird, right?
We're getting really high now. We've reached the exosphere, which is basically the final frontier, that last thin layer where our atmosphere just kind of fades away into the blackness of space. Now, there's another really important region that actually overlaps with some of these upper layers, the ionosphere. This one isn't defined by temperature, but by electricity. It's full of charged particles, and what's its command? Well, it's a very modern-sounding job. It bounces radio waves back to Earth, which is absolutely essential for long-range communication. And that brings us to the seventh and final functional layer, the magnetosphere. Now get this. This one isn't even made of air or gas. It's a totally invisible shield of magnetic energy that's generated by the Earth's core. And its command? It's one of the most important jobs of all. It protects our entire planet from the solar wind, this constant blast of particles from the sun that would literally strip our atmosphere away if it wasn't there.
Okay, so we've got our 7 layers, each with a unique job. But here's the obvious question. If they're all invisible, how on earth do scientists know where one stops and the next one starts? How do they draw the line? Well, for most of these atmospheric layers, the answer's pretty surprising. It's all about temperature.
You see, if you sent a thermometer straight up, the temperature wouldn't just get colder and colder. It does this wild zigzag pattern. It gets colder, then it gets warmer, then it gets insanely cold again. It's these turning points, the exact spots where the temperature suddenly reverses course, that scientists use as the official boundaries between the layers. It's this thermal signature, plus those functional zones like the ionosphere and magnetosphere, that gives us the full 7-part system. So let's recap. Science gives us 7 distinct atmospheric regions, and we now know that each one has a very specific, very important job to do. So now, let's circle all the way back to that 1,400-year-old text and its claim about 7 heavens, each with its own command. When you actually put them side by side, the modern science and the ancient concept, well, the parallels are pretty striking. The troposphere's job is to create weather. The stratosphere's command is to shield us from UV rays.
The ionosphere's command is to manage radio waves. The magnosphere's is to protect us from solar wind. The language is ancient, but the core idea of distinct functional layers seems to line up remarkably well.
But hang on. We have to be honest here and ask the big question. Is this just a really, really crazy coincidence? To be fair, let's put on our skeptic's hat for a minute and look at the main counterarguments. So the most common argument you'll hear is that the number 7 in ancient cultures was often just symbolic. It was used everywhere to mean completeness or perfection, or sometimes just as a stand-in for a lot. So is it possible that 7 heavens was just a poetic way of saying many heavens? Now, the other big part of the skeptic's view is that 7 heavens probably just referred to the 7 things you could see moving in the sky with the naked eye: the sun, the moon, and the 5 visible planets. That was the standard model of the cosmos for thousands of years. But the counter-argument comes right back to the specific wording. The text doesn't just say there are 7 objects. It says each was given a command, a function. Planets are just floating out there. They don't have jobs related to Earth's atmosphere. But these layers, they are defined entirely by their jobs. So let's just boil it down to the basics. For pretty much all of human history, when we looked up, this is what we saw. 1. A single blue sky. Everything our senses told us, everything early science was based on, screamed that the sky is one thing. And yet, when we finally developed the tools to look beyond our senses, what did we find? Not 6, not 8, but a system of exactly 7 distinct functional layers, each doing a specific job to keep our planet alive. For a text to land on that exact number and to tie it specifically to a system of functions, well, at the very least, you have to admit that's a pretty interesting statistical anomaly. So, what's the big takeaway here? After looking at the ancient texts and the modern science, what are we left with? I think this one quote really captures it perfectly. To our eyes, it's just one blue blur, but the ancient text describes 7 distinct layers of operation, a complex machine. And that, right there, is the most important piece of this whole puzzle. The truly amazing parallel isn't just about getting the number 7 right. It's about describing a system where each layer is defined by its unique function, by its command. And that is exactly how modern science understands our atmosphere today. It's like the text provided a functional breakdown of the sky, a classification system, long, long before we had any possible way to actually measure it or even know that structure was there. And that kind of leaves you with one last thought to chew on. It makes you wonder, what other hidden structures, what other complex systems are out there right now, hiding in plain sight, just waiting for us to find the right way to see them?